Now, let's look at some of the ML algorithms pitfalls as well. First pitfall is underfitting when close enough isn't close enough. As you can see that this point doesn't necessarily pass through the line, but the distance between these points and our regression line is way more. So that's why it's called underfitting, as it doesn't capture all the sentiment of the data. Now, if it captures all the sentiment of the data, what would be called overfitting, and it is called memorization, as it is way too specific and we want somewhere in between underfitting and overfitting. Another thing we should be careful about are the data leakage. We should not use our prediction value as input to the model. And sampling bias could occur as well, where it is occurs because of poor choices of training dataset. Example, prediction of item for sales of an entire store chain from a single store's data. Let's say you took data to apply machine learning from an urban store. Now it might not match with the customer behavior of a rural store. So that's why you need to be careful about sampling biases as well and predicting random outcomes. Fair and unfair coin flips, dependent outcomes, these are all random outcomes. So machine learning can only do so much in those areas. Now let's look at the text processing part of machine learning algorithms. Think of search on top of machine learning. All of the common problems apply to the classic linguistics challenge, machine learning to an extent. For instance, tokenization, which breaks down the words in a sentences, stemming or lemmatization, where it checks the grammar of the sentence like walk, walking, walked, walks, or walk. It could also have domain specific dictionaries where it would include company jargon, acronyms, emojis related to a specific field like medical or engineering. And finally, it also depends on the languages used. Like, not everyone writes Shakespearean English or Queen's English, right? The better way to look at it would be through semantic search, where you understand the meaning. It's a better option as it generates processing features in a much more comprehensive manner. Let's look at some of the ML's toolkits, platforms, and libraries. As you can see, the most famous language for machine learning is Python, but we can do machine learning and perform machine learning algorithms through R, Python, and Microsoft Cognitive Toolkit as well. The libraries we can use are scikit-learn, OpenCV, JSAT, Accord.net as a framework API, Azure ML, which is Amazon's famous ML, MLlib, Predication IO. We'll be learning about most of these in subsequent lectures. And we can also operationalize the SQL Server machine learning services as it does machine learning on our SQL data itself, which is a great feature. Now, let's look at the final aspect of the machine learning, which is semi-supervised learning. Can we use unlabeled data to augment a small labeled sample to improve learning? Let's see. From what we have learned, we can say that unlabeled data is missing, which is the most important info. So we'll use uninformed learning or unlabeled learning or unsupervised learning, but maybe it has useful regularities that we can use, right? But we can never be sure, and that's why it is called semi-supervised learning, where based on the learning which is unsupervised, we give it a supervised feedback. So that's the end of our machine learning series. Next, we'll see you soon.